Hello students, I just wanted to give you a quick little example here that hopefully will explain how to work on drawing simple graphs. This is something that has been on previous FAs, and I just want to make sure that you have a chance to prepare for any FAs that we have coming in the future. So, one of the things about drawing a simple graph is you'll be given a situation. Like, let's say that there's a particular enzyme that works, that's known to work at 40 degrees Celsius. That's when the enzyme works the best, right? And so what you'll be asked is show what the optimal temperature of the enzyme would be on a graph, and also show what would happen if that enzyme was at a colder or a hotter environment, right? So I have my graph right here. I have the reaction rate. I have to click real quick. I have to click, all right? I'm not dragging it, but clicking allows me to see I got 10, 20, 30, 40, 50, 60, 70 right there down at the bottom. So already I know, right? It tells me that this enzyme works the best at 40 degrees. 40 degrees is right there in the middle. So I'm going to put my line right here. So let's say that this is the peak right here of my chart, my graph. This is where the optimal temperature of the enzyme is, right? Because that's where it works the best, 40 degrees Celsius. But what would happen if it gets colder or hotter? Thinking about this, well, if the enzyme gets colder, it's not going to be able to allow for the reaction to occur because the particles are moving slower. Chemical reaction isn't happening as quickly because in order for the chemical reaction to happen, substrate and enzymes have to bump into each other. So I can show that as if we decrease the temperature of the enzyme, the reaction rate decreases. But what about the reverse? What happens if I increase the temperature and cause a hotter situation to happen? What's going to happen then? Right? Well, obviously, if I increase the temperature, it's going to cause the enzyme to unfold. All this extra energy is going to cause the enzyme. It can't maintain its shape, so it's going to unfold if I increase the temperature. Right? If it unfolds, it can't perform the reaction. So the rate of the reaction goes down if I increase the temperature, right? So I draw this down right here, just showing that as you increase the temperature, the rate of the reaction decreases, right? So this is kind of show you how the reaction rate works with temperature, right? And we have our highest point right here, right above 40 degrees, showing that that's the best temperature for it, right? And then the same thing works for it'll be the same thing when it comes to pH, right? So let's say this enzyme that works the best at 40 degrees Celsius, let's say that its optimum pH is 19. No, 9. 19 is not possible. Let's say a pH of 9 is the best pH for this enzyme to work at, right? So let me take a quick look. There's 9. So I'm going to show that this right here, this is the optimum pH, right? That's the best pH for it to work at. So then what happens if I increase or lower the pH? If I increase or lower the pH, it's going to lead to the enzyme. The enzyme can't hold its shape. Those hydrogen ions that cause the pH, if there's too many or too few, it affects the charge and all the different chemical things going on in the active site. So as I decrease the pH and go to a lower number, the rate of reaction drops off steeply, right? Drops off steeply, right? That's what happens if I decrease it, right? If I decrease pH, it's going to fall apart. But if I increase pH, it's also going to fall apart, and it's not going to be able to perform the reaction. So if I go other way, it's going to drop steeply, right? So this is a simple little chart right here that shows that the optimum pH is at about 9, and that if you increase or decrease the pH, if you increase or decrease the pH, it's the overall reaction rate is going to go down. All right. I wanted to give you a short little explanation. Hopefully this will serve you well. I hope you guys have a good day today, and I look forward to seeing you later.